Everyone knows the legend of the 454, that rumbling monster that defined American muscle, the engine that powered Chevelle and Corvettes down quarter-mile strips across this country for decades. But what if I told you that Chevrolet just shattered every record, every assumption, every limit we thought existed for a big block V8? What if I told you there's an engine sitting in a crate right now that makes 1,004 horsepower on 93 octane pump gas, revs to 7,000 RPM, and displaces 632 cubic inches? Here's the kicker. It's not turbocharged, it's not supercharged, and it doesn't need exotic race fuel to make that power. This is the story of the ZZ632/1000, Chevrolet's largest and most powerful big block V8 engine ever produced. And to understand just how monumental this achievement really is, we need to go back to where it all began, to a time when Chevrolet first realized that bigger wasn't just better, it was necessary. The year was 1958 and America was changing. The interstate highway system was expanding, suburbs were sprawling outward, and Americans wanted bigger cars, heavier cars, cars that could cruise at 70 miles per hour all day long without breaking a sweat. Chevrolet had introduced its small block V8 just 3 years earlier in 1955. And while that engine was revolutionary, brilliant in its own right, it simply wasn't big enough for what was coming. The engineers at Chevrolet knew they needed something with more displacement, more torque, something that could power the medium-duty trucks and full-size sedans that were about to roll off the assembly lines. So they went to work on what would become known as the W Series, the very first generation of Chevrolet's big block V8 family. That initial engine displaced 348 cubic inches. And while it may seem small by today's standards, it was a giant leap forward. The W Series featured an unusual wedge-shaped combustion chamber located beneath the cylinder head, an interesting design choice that was supposed to simplify manufacturing. But this design had limitations, particularly when it came to high RPM performance, because it required tall, heavy pistons that simply couldn't spin as fast as engineers wanted. Still, the foundation had been laid, and Chevrolet wasn't finished. They were building towards something greater, something that would eventually become the most powerful naturally aspirated production V8 engine in history. By 1961, the W Series had evolved into the legendary 409, an engine that would become immortalized in song and celebrated on drag strips across America. The 409 made serious power for its time, and it proved that Chevrolet could compete with anything Ford or Chrysler threw at them. But competition in the early 1960s was fierce, brutally fierce. Ford was developing its own arsenal of big block engines, and over at Chrysler, the Hemi was making waves in NASCAR. Chevrolet needed something special, something that would blow the competition away at Daytona and prove once and for all that the Bowtie brand could build the fastest engines in America. So in 1963, they unveiled what would become known as the Mystery Motor. It appeared at Daytona Speed Week that year, a 427 cubic inch behemoth that shared some design elements with the W Series, but incorporated revolutionary new features. This wasn't just an evolution, it was a complete rethinking of what a big block could be. The Mystery Motor featured a conventional combustion chamber design, lighter pistons, and the ability to rev higher than anything Chevrolet had built before. Only a handful of these engines were ever produced, approximately 50 units, destined for the 1963 Chevrolet Impala Sport Coupe as part of the RPOZ 11 package. These were drag racing and NASCAR specials, pure competition machines that showed what was possible when engineers pushed the boundaries. The Mystery Motor served its purpose brilliantly. It showed what was possible, and it laid the groundwork for what would become the Mark IV generation, the big block family that would define American muscle for the next 4 decades. Then came 1965, and everything changed. Chevrolet introduced the production version of the Mark IV big block, starting with the 396 cubic inch displacement. This wasn't some limited production race engine that only a few people could buy. This was a real production engine that regular Americans could order in their Chevrolet Chevelles and Impalas. The 396 featured advanced oil control systems, improved wedge-shaped combustion chambers, and a robust design that could handle serious abuse. The bore measured 4.094 inches with a stroke of 3.76 inches, creating that magic 396 cubic inch displacement. But Chevrolet was just getting started. In 1966, they increased the bore to 4.25 inches, while keeping that same 3.76-inch stroke, creating the 427 cubic inch engine that would become legendary. This bore dimension, 4.25 inches, would prove to be foundational, appearing in nearly every big block Chevrolet would build for the next 50 years. The 427 came in multiple configurations, from the relatively mild L36 that made 385 horsepower, all the way up to the race-ready L88 that was officially rated at 430 horsepower. But everyone in the know understood the truth. The L88 was grossly underrated. Testing later revealed these engines were making closer to 550 horsepower, making them some of the most powerful production engines of the 1960s. These 427 engines powered some of the most collectible muscle cars ever built. Corvettes that could run 11-second quarter miles, Camaros that dominated drag strips, and full-size Impalas that could surprise just about anything on the street. But nothing in Detroit lasts forever. By 1970, emissions regulations were tightening, insurance companies were cracking down on high-performance cars, and the muscle car era was entering its final glorious chapter. Chevrolet knew they needed something bigger, something that would stand as the ultimate expression of American V8 power before the curtain came down. So they took that legendary 4.25-inch bore from the 427 and increased the stroke to 4 inches even, creating the 454 cubic inch displacement that would become iconic. The timing was perfect, or perhaps perfectly tragic, depending on how you look at it. The 454 arrived in 1970 with the LS6 designation, and it made 450 horsepower with 500 pound-feet of torque in the Chevelle SS. This was the highest-rated horsepower in a production big block V8 engine of the 1970s, the pinnacle of factory muscle car power. Magazines tested these cars and recorded quarter-mile times in the low 13s, astonishing numbers for a vehicle you could buy from a Chevrolet dealership and drive home. The sound of that LS6 at full throttle was something that people who heard it never forgot, a deep, thunderous roar that announced its presence from blocks away. But the glory days were numbered. By 1971, compression ratios were dropping to accommodate lower-octane unleaded gasoline. Horsepower ratings were falling as emissions equipment strangled the exhaust flow. The Arab oil embargo of 1973 put the final nail in the coffin, and suddenly, big block muscle cars were relics of a bygone era. The LS6's reign as the most powerful big block lasted just 1 year before power started declining due to tightening emission standards, the transition to unleaded gasoline, and the looming oil crisis. But here's what's remarkable. The 454 didn't die. It evolved, it adapted, and it found a new home in America's trucks. Throughout the 1970s, 80s, and 90s, Chevrolet kept building 454 cubic inch big blocks for pickup trucks, vans, and eventually motorhomes. The power numbers were modest by muscle car standards, typically around 230 horsepower, but the torque remained impressive. These engines were workhorses, pulling heavy loads, towing boats and campers, doing the unglamorous but essential work that keeps America moving. In 1987, Chevrolet added electronic fuel injection to the 454, bringing modern technology to the ancient big block architecture. This was the L19 designation, exclusively built for trucks, and it marked a turning point in big block evolution. The EFI system improved vehicle efficiency and helped the engines comply with emissions regulations while maintaining their legendary durability. The Gen 5 big blocks received significant redesigns and upgrades, including one-piece rear seals, 4-bolt main bearing caps, non-adjustable valve trains, and cast aluminum valve covers. The 1991 through 1993 454 SS pickup trucks made 255 horsepower at 4,000 RPM and 405 pound-feet of torque at 2,400 RPM, thanks to dual 2.5-inch catalytic converters. This was the highest performance version of the truck big block, a final reminder of what these engines could do when given proper exhaust flow. By the early 2000s, Chevrolet had developed the Vortec 8100, designated the L18. This beast displaced 496 cubic inches, 8.1 liters, and made up to 340 horsepower with 455 pound-feet of torque. It retained that classic 4.25-inch bore diameter from the 427, but increased the stroke to 4.37 inches, creating one of the most reliable gas engines for applications that needed maximum hauling capacity. The Vortec 8100 powered everything from Chevrolet and GMC heavy-duty pickup trucks to full-size vans, Suburbans, motorhomes, and even marine applications. When the final Vortec 8.1 rolled off the assembly line at GM's Tonawanda engine plant in December 2009, many people thought the big block era was finally, truly over. But Chevrolet had other plans. While production big blocks had ended, Chevrolet Performance and the company's aftermarket performance division kept the flame alive with crate engines. These weren't engines you'd find in new cars on dealer lots, but rather complete engines sold in wooden crates that builders and enthusiasts could install in their own projects. Throughout the 2000s and into the 2010s, Chevrolet Performance offered increasingly powerful big block crate engines. The ZZ502 made just over 500 horsepower and proved immensely popular for street rod builds and truck restorations. The 502 designation came from its displacement of 502 cubic inches, achieved by boring and stroking the basic big block architecture. This engine became Chevrolet's most popular crate engine offering, selling thousands of units to builders who wanted proven reliability with impressive performance at a reasonable price point of around $15,000. Then came the ZZ572, displacing 572 cubic inches and producing 620 horsepower with 650 pound-feet of torque in its performance variants. This engine, developed specifically for GM performance parts, showed what was possible when engineers had complete freedom to push the big block to its limits, without worrying about emissions compliance or corporate fuel economy targets. The ZZ572 featured a tall deck block design, the same architecture that would later underpin the ultimate big block. Performance enthusiasts were amazed that Chevrolet was willing to push displacement boundaries this far, creating engines that dwarfed even the legendary muscle car power plants of the 1970s. The success of these crate engines proved there was still tremendous demand for big block V8s among hot rodders, drag racers, and muscle car restorers who wanted modern reliability with old-school displacement. But engineers at Chevrolet Performance weren't satisfied. They knew the big block architecture could handle more, much more. The question wasn't whether they could build a 1,000-horsepower big block. The question was how far they could push the displacement while maintaining reliability and drivability on pumped gasoline. So they assembled a team led by Russ O'Bliens, GM's director of the Performance and Racing Propulsion team, along with some of the best minds in performance engine development. Engineers who had spent their entire careers thinking about combustion chamber design, valve flow, crankshaft metallurgy, and the 1,000 small details that separate good engines from legendary ones. They had a goal that seemed almost ridiculous: build the biggest, most powerful big block crate engine in history, make it reliable enough to survive hundreds of drag strip passes, and make it run on regular 93-octane pump gas that anyone could buy at a gas station. No exotic race fuel, no additives, just the same gasoline that millions of Americans pump every day. The development process took years of intensive work. Engineers started with the same basic tall deck block architecture that had underpinned the ZZ572, but they pushed every dimension to its absolute limit. They bored the cylinders out to 4.6 inches exactly, and they increased the stroke to 4.75 inches, creating a total displacement of 632 cubic inches, or 10.4 liters in metric terms. To put that in perspective, this single engine displaces more than 2 modern Honda Civics combined. The team knew they were entering uncharted territory, pushing the big block platform beyond anything Chevrolet had attempted in its 60-plus year history of V8 development. Every component had to be rethought, recalculated, and tested to ensure it could survive the incredible stresses that a 1,000-horsepower naturally aspirated engine would generate. The engineers worked closely with GM Racing, drawing on decades of motorsports experience to inform their design decisions. But displacement alone doesn't make power. It's what you do with that displacement that matters, and this is where the real engineering magic happened. The team knew they needed cylinder heads that could flow absolutely massive amounts of air, so they turned to technology developed for pro stock drag racing, the most technologically advanced form of naturally aspirated racing in America. They designed what they called high-flow spread-port cylinder heads, where every single intake port on all 8 cylinders has the exact same length, volume, and layout. This was revolutionary for a big block because traditionally, the ports had varied from cylinder to cylinder due to the staggered design of the engine block and the limitations of conventional casting and machining techniques. But these new heads eliminated those compromises entirely, ensuring that every cylinder breathed exactly the same. The heads were CNC machined from aluminum, with carefully sculpted ports and combustion chambers that promoted efficient burning of the fuel-air mixture. These all-new cylinder heads represented years of development and countless hours of computational fluid dynamics analysis and flow bench testing. Inside the engine, everything was forged and built to withstand incredible stress. The crankshaft was carved from a single piece of forged 4,340 steel, a specialized alloy chosen specifically for its strength and ability to withstand the enormous forces generated when 632 cubic inches worth of pistons are accelerating and decelerating thousands of times per minute. The connecting rods were forged steel H-beam designs, computer analyzed to provide maximum strength with minimum weight, while maintaining the precise length needed for the engine's geometry. The pistons were forged from 2618 aluminum alloy, a high-strength material commonly used in professional racing applications. The block itself was a cast-iron bow-tie block with 4-bolt main caps and a tall deck design, providing the extra height needed to accommodate that long 4.75-inch stroke. The ZZ632's iron block shared a mold with Chevrolet Performance's ZZ572 crate engines, but the castings were machined to accommodate the massive 632 cubic inch displacement. The bore grew by just 0.04 inches compared to the 572 cubic inch V8s, with most of the displacement gain coming from a stroke that was 0.375 inches longer. To provide clearance for that long stroke, engineers modified both the block and the connecting rods, ensuring there would be no interference issues, even at maximum RPM. The camshaft was a billet steel hydraulic roller design, carefully profiled to work with the engine's breathing characteristics and provide strong power across a broad RPM range. Forged aluminum roller-style rocker arms actuated the valves, reducing friction while providing the strength needed to survive 7,000 RPM operation. One of the most impressive aspects of the ZZ632 was its modern technology package. This wasn't some carburetor-fed dinosaur from the 1970s. This was a thoroughly modern Gen 4 big block V8 with electronic fuel injection for precise fuel control and stunning output on pump gas. The induction system featured 8-port fuel injectors that delivered precisely metered amounts of gasoline directly into the intake ports, controlled by a pre-programmed self-learning engine control unit that came included with the engine. This ECU continuously monitored engine conditions and adjusted fuel delivery and ignition timing for optimal performance. The ignition system was a crank trigger setup with coil near plug configuration, where individual ignition coils sat directly above each spark plug. This eliminated the long spark plug wires that were prone to interference and power loss on traditional distributor-based ignition systems. The throttle body was a 4500 style design with a dominator flange, capable of flowing the massive amounts of air this engine demanded. Due to crate fitment constraints, the throttle body shipped uninstalled and had to be fitted by the engine installer. But this was a minor inconvenience, given the spectacular performance the complete package delivered. During development, the engineering team subjected a single ZZ632 engine to more than 200 simulated drag strip passes on a dynamometer, and it survived every single one without failure. This wasn't just a dyno queen that made big numbers for 5 minutes before exploding. This was a genuinely durable engine that could be used, abused, and trusted. The testing protocol was brutal, designed to replicate the kind of abuse that drag racers dish out weekend after weekend. Hard launches, red line shifts, full throttle blasts, followed by rapid deceleration, the engine handled it all. When Chevrolet Performance finally unveiled the ZZ632/1000 at the SEMA show in Las Vegas. In November 2021, the automotive world was stunned. The official numbers were almost hard to believe. 1,004 horsepower at 6,600 RPM and 876 pound-feet of torque at 5,600 RPM. The engine could safely rev to a maximum recommended RPM of 7,000, a number that would have been considered impossible for a big block V8 just a generation earlier. This was more power than multiple Dodge Vipers combined, more torque than many diesel semi-truck engines, all from a naturally aspirated gasoline V8 that could fit in a relatively standard engine bay. Russ O'Blien stood on stage at SEMA and delivered words that perfectly captured what this engine represented. "This is the biggest, baddest crate engine we've ever built." The ZZ632 sits at the top of our unparalleled crate engine lineup as the king of performance. It delivers incredible power, and it does it on pump gas. Those words carried weight because they were absolutely true. This engine was the king, the undisputed champion, the final word in big block Phi-8 development. Chevrolet marketed it as their largest and most powerful big block Phi-8 ever produced. And there was no hyperbole in that claim. This was the culmination of 63 years of big block development, from that first 348 cubic inch W series in 1958 to this 10.4-liter monster that made over 1,000 horsepower. Think about that journey for a moment. In 1958, engineers were thrilled to extract maybe 250 horsepower from 348 cubic inches. Now, in the 21st century, their successors had created an engine that made over 1,000 horsepower from 632 cubic inches and did it reliably, repeatedly on 93-octane pump gas that costs maybe $4 a gallon at your local gas station. Of course, building an engine this powerful presented unique challenges for installers. The ZZ632 was externally larger than previous big block engines, and Chevrolet was keen to remind people to always measure the engine bay before ordering one, even if the engine bay could accommodate a normal big block V8 with ease. The cylinder head exhaust ports featured a unique design derived from those pro stock racing heads that required a custom exhaust system. You couldn't just bolt on standard big block headers and expect them to fit. The port configuration was different, optimized for maximum flow rather than ease of installation. The engine required an EFI-compatible high-pressure fuel pump, capable of feeding those 8 port injectors with sufficient volume and pressure. It needed a starter motor robust enough to crank over 632 cubic inches of 12-to-1 compression ratio. For manual transmission applications, an internally balanced flywheel was required, carefully matched to the engine's internal balance to prevent vibration at high RPM. But for builders and enthusiasts willing to tackle these challenges, the reward was extraordinary. Imagine dropping this engine into a classic Chevelle or Camaro, cars that originally came with 300 or 400 horsepower when they were new. Now imagine that same car with 1,004 horsepower, still drivable on the street, still able to run on pump gas, you can buy anywhere. Quarter-mile times in the 8-second range suddenly became achievable for street-driven cars, numbers that were once the exclusive domain of professional drag racers, with exotic, unreliable engines that needed constant maintenance and rebuilding. The ZZ632 was built for competition use, designed and intended for vehicles operated exclusively for racing or organized competition on courses separate from public streets or highways. This designation was necessary due to emissions regulations. An engine this powerful simply couldn't meet modern EPA standards for street-legal vehicles. But the engineering excellence was accessible to enthusiasts through Chevrolet performance dealers across the country. One builder documented his experience installing a ZZ632 in his 1967 Chevelle and adding a Magnuson supercharger on top of the already spectacular naturally aspirated output. His dyno results showed numbers well over 1,500 horsepower, figures that would have seemed like pure fantasy just 20 years ago. When deliveries began in early 2022, the ZZ632/1000 retailed for around $37,000, making it Chevrolet Performance's most expensive crate engine by a significant margin. But for that money, buyers received a complete, ready-to-install engine with a modern EFI system, professional-grade engine management, and a warranty backed by General Motors. Examples sold at auction, like the unit that crossed the block at Bring a Trailer in July 2024, commanded prices of $31,000 even for unused engines, testament to the engine's desirability and collectability. It's worth noting how the ZZ632 connects to the entire lineage of Chevrolet big blocks. That 4.25-inch bore diameter that appeared in the original 427 back in 1966. Engineers maintain that same basic dimension philosophy, just pushed slightly larger to 4.6 inches for the ultimate displacement. The basic block architecture, the placement of the cylinders, the fundamental design philosophy, all of it traces back to those original Mark IV engines from the muscle car era. But where those engines made 400 horsepower and were considered astonishingly powerful for their time, the ZZ632 makes more than twice that power while being more reliable, more efficient, and easier to tune. This represents genuine progress, the accumulation of decades of knowledge and experience. Every lesson learned from blown head gaskets in 1970 Chevelle, every metallurgical advancement from decades of racing development, every computational fluid dynamics simulation and dyno test, all of it contributed to making the ZZ632 possible. Among the key engineers who contributed to this legacy was Ron Sperry, a powertrain engineer who designed the symmetrical port cylinder heads. These RSX symmetrical port heads were named in his honor, representing one of his final accomplishments in more than 50 years, working on General Motors, performance and racing engines. Sperry had also introduced symmetrical ports to Chevy's iconic small block V8 with the Gen 3 LS1 engine that debuted in the 1997 Chevrolet Corvette. So this technology represented the culmination of his life's work, applied to the big block platform. The ZZ632 also represents something deeper, something almost philosophical about American automotive culture. In an era when electric vehicles are rapidly gaining market share, when turbocharged four-cylinder engines are replacing V8s in performance cars, when environmental regulations are pushing automakers towards smaller, more efficient power plants, Chevrolet built the biggest, most powerful naturally aspirated V8 ever created. This wasn't a practical business decision. No modern vehicle manufacturer needs a 10.4-liter V8 for any rational purpose. This was an act of passion, a statement that the American V8 isn't dead, that there are still engineers who care about displacement and horsepower and the visceral thrill of a big block engine at full throttle. It's a reminder that sometimes engineering isn't just about efficiency and practicality. Sometimes it's about pushing boundaries, about seeing what's possible, about creating something purely for the joy and excitement it brings. The ZZ632 proves that American V8 engines aren't relics of the past. They're living, evolving machines that continue to push boundaries and shatter expectations. Today, the ZZ632/1000 stands as a monument to American automotive engineering excellence. It's available through Chevrolet performance dealers across the country, ready to be installed in street rods, race cars, and custom builds of every description. Builders have fitted these engines into classic Camaros and Chevelle, into hot rods and pro touring builds, even into trucks and off-road vehicles for people who want truly insane amounts of power. The engine has achieved legendary status in the few short years since its introduction, joining the ranks of the LS6454, BL88427, and other truly great American performance engines. It sits at the top of Chevrolet's big block timeline, the final evolution of an engine family that began in 1958 and culminated in 2021 with the most powerful iteration ever conceived. And while we don't know what the future holds, whether Chevrolet will push displacement even further, whether new technologies will emerge to extract even more power, whether electric power will eventually render these engines obsolete, we know that the ZZ632 represents a pinnacle, a moment when everything came together perfectly to create the ultimate expression of big block V8 power. The legacy of the big block is secure. From the W Series 348 that started it all, through the legendary 409, the mystery motor 427, the Mark IV production 427, with its incredible L88 variant, the mighty 454 LS6 that ruled the muscle car era, the truck engines that kept the flame alive through the dark decades, the Vortec 8.1 that served as the last production big block, the crate engines that showed what was possible without emissions constraints, and finally to the ZZ632 that pushed every boundary to its absolute limit. This is a family of engines that powered America for over 60 years. They powered farm trucks hauling grain to market and race cars setting records at Bonneville. They powered McLaren Can-Am cars to victories and full-size Cadillacs cruising down highways. They powered the dreams of hot rodders and the ambitions of drag racers. And now, in its ultimate form, the big block V8 makes 1,004 horsepower, revs to 7,000 RPM, runs on pump gas, and proves that American engineering excellence is alive and well. So here's what it all means. The most powerful big block V8 engine of all time isn't some ancient muscle car engine from the 1970s. It's not even from the 1990s or 2000s. It's from 2021, built with modern technology, advanced metallurgy, pro-stock-derived cylinder heads, electronic fuel injection, and old-school displacement to create 1,004 horsepower on 93-octane pump gas. The ZZ632 proves that there's still room in this world for engines that make no practical sense, engines built purely for the joy of acceleration and the thrill of power. It proves that the spirit that created the 409, the 427, and the LS6 is alive and well in the 21st century, carried forward by engineers who understand that sometimes the only replacement for displacement is even more displacement. This engine stands as proof that passion still drives innovation, that there are still engineers at General Motors who wake up every morning thinking about how to make more horsepower, more torque, more excitement. It demonstrates that even in an age of hybrid powertrains and electric vehicles, there's value in celebrating the raw, unfiltered experience of internal combustion at its absolute peak. The ZZ632 represents the culmination of everything Chevrolet learned across 6 decades of big block development. Every victory, every failure, every breakthrough distilled into one magnificent engine. The ZZ632/1000 isn't just an engine, it's a statement. A declaration that American performance lives on, that big blocks aren't dead, and that the best big block ever built wasn't made in the muscle car era. It was made right now, in our time, and it's absolutely spectacular. Have you ever dreamed of owning one? Can you imagine the feeling of turning the key on 1,004 horsepower of naturally aspirated American V8 thunder? What would you build around this incredible engine? A classic muscle car, a modern pro touring build, or something completely unexpected? I'd love to hear your thoughts in the comments below. And if you enjoyed this deep dive into the most powerful big block V8 ever created, subscribe for more forgotten American legends and engineering achievements that shaped our automotive world.